In the graph here, we've got a quadratic equation in red, and this has got an equation x squared minus 6x plus a constant. And we're representing that quadratic on this vertical axis, which is the y, and this horizontal axis, which is the x. So this is a real x real, and we've got y real. And then this blue axis, or the green, is going to be the z-axis, or the imaginary axis. So we've got coming out is the imaginary axis. And then we're going to have a look at what happens as we change the c value of the equation. So at the moment, the two roots for this quadratic equation are along the real x-axis. So we've got a root here, and we've got a root here. So we've got two real roots. So if I increase the c value, just have a think of what you think is going to happen if I increase the c value. So now let's try and see if you were correct. So I'm going to move the c value up. So we're going from 6.6, 6.8, 6.9, increase it a bit further. So as the quadratic moves upwards, the two real roots are getting closer and closer together. So, and we're going to see them actually close together. So when we get to 9, this would be a perfect square. So x squared minus 6x plus 9 is a perfect square. And we've got one real root here, because it touches the x-axis. So what happens now as I increase the c value? Well, it's probably going to move upwards still, which now means we've got no real roots. But we can see we're now going out along our imaginary axis. And we're going out backwards and out forwards at the same distance. So we've now got two imaginary or complex roots. And as we increase the c value, those two complex roots get further and further apart. So that's a way of visualizing the difference between the real roots and the imaginary roots. So as we approach c is 9, the complex roots get closer and closer together until they meet at this point here, and then we start getting our two real roots.